Welcome back, 8th grade. Today we're talking about an even more complicated type of equation, and it's when we have variables on both sides of the equal sign. So we're used to just choosing a variable and isolating it by undoing what's been done, but sometimes we have a few steps before that, so let's check it out and see what these guys look like. But first, the notes. We have to do a little review of terms, what terms are and how we're going to use them. And the idea is that a term is an algebraic value. So it could be something like 7. That would be a constant. Or it could be like 2x. That's a value. We don't know exactly what it is because we don't know what x is, but we know that this has a specific value. It could also be something like 5j squared. So these are all examples of terms. But the thing to know is that if you're trying to figure out where does one term end and another term begin, terms are separated by positive and negative signs. And the best way to just look at this is you can just kind of underline different terms in different sections, and you stop underlining when you reach a positive or not positive or negative, addition or subtraction signs. Here's a hint though, whenever you see a subtraction sign, you're going to want to change it to addition, play add ops, and count the next term as a negative value. So that maybe that should be an additional note, but we'll just review it in class. The next note you need to know is that like terms have the same variable and exponent. And why are like terms important? Well, they can be combined. So we're not going to combine 3 with 5x because they describe completely different things. But we can combine 5x and negative 3x because they're talking about the same sort of thing, just different amounts. And we can combine those different amounts of the same thing. The last thing to know is that when we're solving equations that have terms on both sides, it helps to keep the big positives on their own side. And you're going to see what I'm talking about in just a second. So make sure you have those notes and let's get to it. Again, I want to show you a picture just to try and help us understand. And I know this looks a lot more daunting. It looks a lot more confusing than our ones in the past have. But let's just take it step by step and try and say first, what does each side have on it? Well, the left side of the scales of justice is going to have 3 y's, they're positive because they're blue, and 3 negatives. So we have 3y, you could say minus negative, or minus 3, or plus 3 negatives, but I'm going to say plus 3 negatives. What does the right side have? Well, it has 4 red y's, or negative 4 y's, negative 4y, and it also has 4. All right, so we're looking at this. So we got it written as an equation. Now, what am I going to want to do? Well, I said earlier that it helps to keep the big positives on their own side. And I know I need to get these y's to be together. So what am I going to do? Well, let's look at the picture. What I would like to do here is I'm going to say, I don't like these negative y's. How can I cancel them out? How can I get rid of y's on one side? Because we're not going to be able to solve it if we have y's on both sides. Well, I know that I could just take away negatives. But I don't have any red y's to take away. I know that I can cancel a negative value by adding the same positive value. So I know that if I add 4y to both sides, all these y's are now paired away. They're paired away, they're going to cancel out. So I'm going to first get those guys and say I need to add them to the right side as well. But what they're going to do is they're going to cancel out these negative y's for me. So these are all going to cancel each other out. And hopefully that makes sense, that a negative value and a positive value cancel each other out. So now how does that look on our equation? Well, what we said was we don't like these 4 y's. We're going to add 4 y's. We put 4 positives to cancel out those 4 negative y's. And now you can see that what I'm going to do is I'm not going to add that 4y to positive 4 because they don't have the same variable. They're not like terms, we can't combine them. But they do cancel out there. Again, on the left side, I'm not going to do anything with negative 3 and positive 4y. They have different variables. Well, one has a variable, the other doesn't. So they don't combine well. But 3y plus 4 more y's, that's just a total of 7 y's. That's easy to think about. Those like terms go together. Now you have 7y plus negative 3, and that's exactly what it looks like. 7y plus negative 3 equals 4. Now we're just solving this like a normal two-step equation. We're going to say omega is going to tell us to undo the addition and subtraction first. So how do I cancel out negative 3? By positive 3, we'll 0 pair those out. And we're going to have these cancel. If 7y is going to be equal to 7. Well, I know that if 7 of these y boxes are equal to 7 after I cancel out these three guys by adding 3 positives, So I added those 3 positives and they canceled out. If I know that I have 7y's and they're equal to 7 positives, well, I know each of those y boxes is just holding 1 positive. And we'll just divide by 7 on both sides, divide it into 7 different groups, and each group is going to have 1 in it. So y is equal to 1 in this case. Now I know that probably looked intimidating to start, but hopefully it was pretty obvious exactly what we were going through to solve that. We're just going to try and keep the positive y's on its own side, but then cancel out the variable term on the other side. What does this look like in other sorts of practice? Well, let's check it out. Without drawing pictures, we can just go through our equation solving steps and say, oh no, I have this m term on both sides. Well, I have 4 m's on the right and 2 m's on the left. I'm just going to start canceling out the m's. How can I make these 2 m's disappear so I only have m terms on one side? I can subtract 2m from both sides. What are we going to be left with? We're going to have 4. That was awful. We're going to have 2m plus 7 is equal to -3. Next step is to cancel out the addition. Remember, subtracting 7 is the same as adding -7. If 2m is equal to -10, I can divide both sides by 2. And hopefully you'll see that the answer we're going to get is m is equal to -5. Now again, I could plug in -5 and make sure that both sides would come out equal. That'd be a great way to check. But that's what we got so far. Let's move on to the next one. Make sure you have those notes written down more neatly than I have them written, please. And let's check this guy out. Now we have 3 times the quantity of h plus 7 equals -6 plus h. Now, we talked in the last video about how in this situation, when you see a number on the outside of a parenthetical sum or difference, you can either say, okay, we can undo the division first, or we can distribute. This is a case where we're going to need to distribute, because if you did want to divide first, well, now you have this annoying denominator of 3. h over 3 is kind of annoying. I would much rather distribute first. So that's why you need to be able to pick out the distribute property. So here we go. We're going to say 3 times the sum is the same as multiplying 3 times each of the parts. So we have 3h plus 3 times 7 is 21. Distributive property of multiplication over addition is going to be equal to -6 plus h. Now we're in a similar situation to our last problem, in which we say we have 3 h's on the left, we have 1 h on the right. I want to keep more positives together, so I'm going to subtract h from both sides. If you subtracted 3h from both sides, it would work out fine. It's just going to be a little bit harder for most people to keep track of your positives and negatives and get the right answer. Well, this is not going to work out as neatly as usual, but that's okay. Now we just have a normal two-step equation. Omega is going to tell us undo addition and subtraction first. Subtract 21. Again, subtracting 21 is the same as adding -21. That makes it easier for me to think about. I say if you have 6 negatives and 21 more negatives, then you just have 27 negatives, or -27. Finally, we need to undo multiplication. How do you undo multiplication by 2? By dividing by 2. And h is going to be equal to 13, -13, negative divided by positive is -13.5. There you go. Look for that distributive property. That distributive property is really going to help you to solve these. And then again, I would just usually try and keep the bigger value of my variable term on its own side and cancel it from the other side with the inverse operation. So in this case, we said we want to get rid of 2 m's on this side. Let's subtract 2 m's from both sides. In this case, we wanted to get rid of an h from this side so that we could solve this equation. So we just subtracted h from both sides. All right, best of luck on your practice problems. Here they are. Number 1, 3m minus 20 is equal to 25 minus 12m. Show me what you get there. And number 2, 5 times the quantity of x plus 4 is equal to 4x minus 13. Best of luck. I'll catch you later.